Ready to master secure cloud networking? Welcome to the EA Strategy Masterclass on Azure Virtual Networks. This video isn't just an intro, it's an uninterrupted learning path for fundamentals, planning, security, and deployment. Over the course of the video, you will learn global location strategy, structured naming, zero trust isolation, and critical allocation methods. Why watch the full video? Because when you complete the entire masterclass, you don't just scale your knowledge, you earn your learning certificate. Scale your career. Watch until the very end. Unlock your powerful future. Your old on-prem world was like buying land, pouring concrete, and running a maze of noisy, power-hungry servers. Growth meant more buildings, more cables, more maintenance. Today, organizations escape all that by moving to the cloud. Imagine the cloud as a giant digital skyscraper in Microsoft Azure. Instead of building your own data center, you simply rent a secure, flexible office suite. Azure handles the physical hardware. You focus on delivering services. Inside that skyscraper sits your private digital estate, the Azure Virtual Network. It's the cloud version of your old physical network, isolating your virtual machines, databases, and apps so they communicate safely. The biggest shift is how communication works. Traditional networks shouted using broadcast traffic. In a VNet, communication is precise and directed. Every packet knows exactly where it's going. You design the logical layout, and Azure removes the chaos of cables, racks, and on-prem headaches. Before moving into the cloud, you have to do some digital urban planning to set up your estate. First, master the art of the name. Every Azure resource needs a strict, clear name within its resource group. Think of this group as a project filing cabinet. Don't just call it My Network. Use specific names so you always know exactly what and where it is. Next, choose your geographic location wisely. You must consider strict legal compliance to avoid massive fines, proximity to your users for lightning-fast speeds, and disaster backup plans, using availability zones so your business never skips a single beat. Your VNet is like a secure digital neighborhood. Every device inside it needs its own unique address, so data travels safely, just like houses on a street. To build that neighborhood, use two blueprints: IPv4, the older format that's running out, and IPv6, the newer format with practically unlimited addresses. Inside your network, you use private IPs, similar to an office's internal phone extensions, protected from the outside world. The biggest rule for future growth is avoiding IP overlap. If two networks use the same addresses, they can't connect later. A master IP plan keeps every cloud and office network unique, ensuring smooth expansion. To avoid chaos in your digital neighborhood, you must divide your large virtual network into distinct, secure zones called subnets. This creates logical perimeters, isolating your public web storefronts from heavily guarded internal databases. By acting as digital bouncers, this compartmentalization stops security threats in their tracks. Just remember, Azure always collects a 5-address tax for internal plumbing in every subnet, so plan your sizing carefully. Finally, always prepare for special cloud services that demand their own dedicated, strictly named spaces before finalizing your layout. With the virtual network fully built, the system assigned digital addresses to new resources. It utilized dynamic allocation, which functioned exactly like valet parking to keep the network fluid and automated. For legacy software, administrators reserved static IPs directly within the Azure portal to avoid system clashes. IT professionals deployed these complex environments rapidly, using command line interfaces after they verified available regional quotas. Finally, they deleted the entire resource group, which acted as an instant eraser to stop the ongoing billing clock. We built Azure Virtual Networks. We planned the digital estate, enforced strict names, and selected secure regions. Next, we mapped private IP blueprints which prevented overlaps. We then divided the space into isolated subnets, which enforced zero trust and stopped lateral threats. Finally, we deployed resources, assigned dynamic addresses via command line tools, and deleted the resource groups. This action completely stopped the billing clock.